Hey everybody, it's Russ here at Shaper Sessions. That's right, just me today. Jake is out on a much-deserved break, so I'm taking this opportunity to dive into one of my personal favorite topics, router bits. I'm a CNC nerd at heart. I've been using router bits of a variety of types for a long time. We're going to talk about all of them, and we're going to go into the deep, deep details on everything that you would ever want to know and more about router bits. The reason for that, we have an accessories sale going on. It's 15% off all accessories on shapertools.com. If you order over $100, that's free shipping. If you order over $150, you get a free router bits poster that one of my colleagues designed. It's really, really phenomenal and huge. Also, we'll show some pictures of that in a bit. But yeah, today is all about router bits, all you wanted to know and more. If this is your first time watching Shaper Sessions, this is our bi-weekly live stream where we cover everything that you need to know about Origin, our handheld CNC router. This show's a little bit of a one-off because we're actually not going to be doing that many Origin demos, but what I hope with this is that it's actually widely applicable to anybody with a CNC machine, anybody that uses router bits, or even if you use router bits in just a plunge router, if you don't own Origin right now, you're going to learn a lot that's going to help you with your practice there. So if you like this video, share it with your friends. I hope they get something out of it. You might even want to watch it twice. We're doing this live right now, and later this week, probably tomorrow, this video is going to be put up on YouTube so that you can come back and watch it again later, maybe 2 or 3 times, because there's a lot of info. Now, the reason that you tune in live is because we do a live Q&A at the end. We do a giveaway also at the end. We're going to give away some cool router bits. And to enter that giveaway, there's going to be a poll question that we're going to bring up about halfway through the show. And just answer that poll question, and you'll be entered to win the giveaway. That's all there is to it. For the Q&A, we're taking questions throughout the whole show. We've got Ted in the chat today. Ted's going to be collecting a lot of those questions. He's going to be answering some text questions as we go, and some questions that deserve a demo he's going to send to me, and we will do that demo live at the end. Now, those live Q&A demos are only for live viewers, so thank you for being here today. And if you're watching this after the fact on YouTube, make sure you join us for the next Shaper session. That's going to be 2 Thursdays from now. Yeah, before we dive in, let's just show off that accessories sale. Goose, could we pull up the laptop over here? We've got Goose on the switchboard. You can find this at shapertools.com/accessories, I believe, or /store/accessories. Ted's got the link to that. He's going to drop that in the chat. You just go to shapertools.com, browse over here to accessories. We've even got a whole tab for it right here, accessories sale. And this is going to show you everything that's on sale right here. So we've got all kinds of cool stuff, connected caliper, edge mortising adapter, and then our whole catalog of router bits. Everything's 15% off. So check that out after you watch this show. Don't click away just yet, because you're about to learn a ton. So thanks for that, Goose. Let's get started. Why do we care about router bits? I've got a really fun question posed by my colleague Andy originally, so shout out to Andy for this analogy. What is Origin without a router bit? It's a really smart tool, but you really won't be able to do anything about it. And the fun image that Andy came up with was, think of a Tesla without any wheels or tires. It's a really smart machine, but you're not going to be able to get anywhere with it. So you have to use router bits with a router of any kind. They're really, really important. It's where the router meets the wood. It's where all the cutting action happens. And my goal for you for today's show is to help you know, how do you know whether a router bit is going to work for your Origin project? Not just with Origin in general, but also specifically for the projects that you are trying to do. Because you've got different materials, you've got different geometries that you're trying to cut, et cetera, et cetera. So, okay. With that said, let's dive in. I've got a whole bundle of router bits over here. I'm going to pick out just our stock 1/4 inch by 3/4 up spiral router bit, and I'm going to put this on the special bit cam that Goose set up for me here. I'm actually going to put this way. Yeah, can you guys see that? Okay, nice. Bit cam in action. We're going to talk about the parts of a router bit because there's a lot that goes into this small little piece of equipment. Okay, parts of a router bit. The part that does all the cutting, that's the edges. That's from here down. This is a 1/4 inch diameter by 3/4 inch cutting length router bit. And that 3/4 inch cutting length is a really important number. That's the length of these cutting flutes. With this router bit, the length of those cutting flutes is actually basically the entire usable length of the router bit. And I'll show you some router bits later where there's an exception to that. But cutting length and the length of the edges there. We also have the overall length of the router bit from top to bottom. That includes the cutting length, any clearance length, which this router bit doesn't have, but I'll show you one shortly, and the shank length. Those 3 lengths all total up to the total length of the router bit. And the longer the router bit is, the deeper you are going to be able to cut with it. This is a modestly lengthed router bit. I think it's 2.5 inches or so. We make longer router bits. The longest one that we make, I believe, is our 8x35 millimeter router bit. And that allows you to take full advantage of Origin's entire range of Z-axis travel. This router bit, no matter how far out you stick it, you're really not going to get the full length of Origin's Z-axis travel. So that's one reason why you might want to upgrade router bits there. This is a 2-flute router bit, so you can see if I kind of carefully spin this router bit here, we've got 2 flutes. We've got one here and one over here. Those helix all the way up the router bit. Bits come in all different kinds of flute numbers. We sell 1, 2, and 3 fluted router bits, but there are applications where you might want router bits with 4 flutes. There are applications where you could even, not for Origin probably, but for maybe a metal mill, you would buy an end mill with 6 or more flutes even. 2 is a great balanced number, kind of middle of the road for woodworking. So we've got 2 flutes here. Again, we've got the shank. This is a 1/4 inch diameter shank, and that fits exactly in a 1/4 inch collet. You want, with Origin, that shank diameter to exactly match the collet diameter. So Origin comes with all 1/4 inch shank router bits in the US stock and a 1/4 inch collet. We also make other sizes of collet, the 8mm, 6mm, 3mm, and 1/8 inch collet, which we'll talk about a little bit more later. And then on this router bit, I'm actually going to grab a different one to show you a couple of markings. The last thing that I want to talk about on router bits in general are some markings that you might see on the side. Now, this isn't a router bit that we sell. I don't believe this is a Festool router bit. Actually, you can see we got the Festool branding right there. Goose says, point at it from the other side. I must be casting a shadow. How's that, Goose? Better? Nice, thank you. Festool router bit. You can see we've got all kinds of laser markings on this shank. These tell you a lot about the geometry of the router bit. So in case you lose the case, in case you don't have calipers, you've got some measurements on there. If you've got calipers, you can always measure this stuff. But the one that I really want to point out is this mark, which is a line with an arrow sideways. It kind of looks like the letter K. Actually, let me switch this around. And so you can see that letter K. We call this literally the K mark. And the K mark is a suggestion of the minimum insertion distance for this router bit in the collet. So ideally, when you use this router bit in Origin, you want to put that collet in all the way so that it covers that K mark, or at least is right up to it. And that's all the stuff on the surface there. Okay, so that's where we're going to start. That's router bit geometry. Now we're going to dive in to every little bit of that in like even more detail. One thing to keep in mind though is not just what shape the router bit is, but what material it is. So this is a solid carbide router bit. I'm going to walk you through a couple different materials here because materials are really fun. When you get started with woodworking or especially with drills and metalworking, you might start with this, which is a high-speed steel router bit. There are 4 basic materials that we're going to cover. The first one is high-speed steel. The second one is brazed carbide. The third one is solid carbide. The fourth one is carbide insert. These are kind of the 4 ways that router bit can be constructed. Let's go back to the router cam here, or the bit cam. This is a high-speed steel router bit. It's made from literally steel. High speed means that it's an alloy that's meant to be used at high material removal rates, which means that it's a specific alloy. It's very temperature resistant. It's very durable. It's a little more brittle than a lot of other steels, but not nearly as brittle as carbide. It takes a really good edge. But the trade-off there is that these are really only good up to about 500 degrees or so, and then they lose their temper and the edge starts to degrade very, very quickly, as opposed to a carbide tool. Now let's show off a brazed carbide tool because this is the next step up. So if we look here, we've got a brazed carbide router bit. And what brazed carbide means is that you see these carbide edges. These are solid carbide, which is like a type of ceramic, basically. And they are brazed, which is like being glued together with metal, basically, or low temperature welded to a steel shank. And that's kind of the best of both worlds in some ways. One way is that the carbide edges are much more durable than the high-speed steel edges. It's still a low-cost router bit because it's primarily made with steel instead of primarily being ground out of solid, super strong, but brittle carbide. One downside here is that you only pretty much get straight flutes, and we'll talk about flute geometry shortly, but you pretty much only get straight flutes with brazed carbide bits because these pieces, they grind them flat. It's the easiest way to make them, and then it's the easiest to attach them flat as well. So you don't get really complex edge geometry with these. They're also really unlikely to be center cutting, which is a term that we'll cover in a second. Maybe next step up from that in terms of fanciness, and these are most of the router bits that we sell is solid carbide here. Solid carbide bits are going to have the most durability. They're going to have very sharp edges. Actually, carbide is not quite as sharpenable to a super, super high edge sharpness as high-speed steel is, but very sharp edges with carbide and much more durable. They're going to be much more temperature resistant, but the downside there is that they are a little bit more expensive. Now, at Shaper, we believe that the expense is well worth it with the solid carbide router bits, so it's pretty much all that we sell unless there's like hardly any way to make the router bit without brazing it together. So today we're pretty much just going to be working with solid carbide router bits, and these are the ones that we use on the show. Now, before I show you an insert bit, I want to show you something really interesting, because if you look at, actually, let's go back to the bit cam here. If you look at these two next to each other, the high-speed steel and the carbide, you might think, well, how the heck do I know which one is which? They are a slightly different color. You can see that the high-speed steel bit is a little bit whiter of a gray, and the carbide bit is a little bit blacker of a gray. But here is something crazy. Let me pull out the scale. Carbide is incredibly dense, even denser than steel. So I've got my coffee scale here. We're going to pull it up, and we're going to weigh these two and see what the difference is between them. We'll tear that. Now, is that in frame, Goose? That looks pretty good. Here's that high-speed steel bit. This bit, 15.6 grams. Now I'm going to pull up our solid carbide stock 1/4 by 3/4 router bit, which is actually considerably smaller than this. You can see these two side by side. Okay, so 15.6 grams for this one, and 22.3 there. So much denser. The carbide, kind of an indicator of quality. When you're buying anything, you kind of just want it to be heavier. Like, think of stereo equipment. If you've got stereo equipment that you can lift with your pinky, you kind of want it to have some heft. You know, there's good tubes in there. So, high-speed steel versus solid carbide. Now, last but not least, let me show you something crazy. And we don't use these with Origin often because it's hard to find a bit that is small enough with this kind of construction that works with Origin. But I know our helical head planer works this way. This is a carbide insert bit. So this is even too big to show on that bit camera. So let's look at this right here. Can you guys see this? So this is a steel body that has carbide inserts just screwed to it. And Really, the reason for this is because if you're making this whole thing, you don't want this whole thing to be solid carbide. It would be a massive waste of resources to grind that whole thing down just to your cutting edges. It would be really difficult to maintain. It would be really brittle. It would not be durable if you dropped it. What you get with the carbide inserts is these are indexable. They're rotatable, so they each have 4 sides. Once one side dulls, you can rotate that. And yeah, it's a much more balanced set of characteristics between durability, sharpness, cost, all of these things. So that's your 3rd option with carbide and your 4th option overall. Okay, router bit geometry, router bit materials. I told you this was going to be a lot of information. Please, please, please ask questions. And again, we will cover those questions later at the end. Okay, perfect. Nice. One piece of kit that often is high-speed steel is a drill bit. And before we continue on with router bit geometry, I wanted to address a question that a coworker had before the start of this show. Audrey said, "Hey Russ, what's the difference between a drill bit and a router bit?" Drill bits are typically steel. The reason for that is because the steel is much more resilient. Drills do a lot more wobbling and vibrating when they're being used, and so it's actually really, really difficult to use a carbide drill bit safely, even in like a nice woodworker's drill press. You would probably want a very rigid CNC mill to do that. We're about to get into edge geometry, and one thing that I want you to note, sorry Goose, I was taking a little while on that one. One thing that I want you to note here is if we come in and look at where, here we go, we can see this. If you look at where the shank of this drill bit starts to meet the edge of this flute right here, you can see as I rotate this around, it's going to be hard to tell with the light, but you can see that this is a completely smooth transition right here. The side of the drill bit is not meant to cut laterally. Drill bits just go straight down. The sharp edges of them are on the bottom. They are ground away much more in the flutes, so they're not as rigid. And these edges are not sharpened, so they're going to be wobbly. They don't have a flat bottom. They're not center cutting at the bottom, which we're going to talk about in a minute, as opposed to a router bit, which has these edges sharpened, has the bottom sharpened and center cutting, and often flat to give you that flat profile. And so let's talk a little bit more about the edge geometry, very specifically of a router bit and the different types of that. The number one most important thing when we talk about the edge geometry of a router bit is whether it's upcutting, downcutting, straight fluted, or a compression bit. This is an upcut router bit here, and what an upcutting router bit does is it extracts the chips up and out of the cut that you're making. It literally cuts up, kind of as it's spiraling around, the edge kind of looks like it's moving upward. Downcutting router bit cuts more downward. It pushes those chips down deep into the cut. That will often give you a slightly better edge quality at the top, especially if your router bit is dull or you're using lower grade materials. But if you don't have ideal dust extraction, you're going to get a lot more friction because that down cutting router bit is pushing those chips down into the cut. And I have a down cutting bit here to show you. Let's look at these two side by side. We've got this upcutting bit and this down cutting bit. Now, the sharp edge of both of these bits is on the left side here. So they're going to want to rotate this way across the screen. Now watch as I spin this bit. Watch how that cutting edge looks like it's pushing downward, as opposed to this bit, which looks like it's pulling upward as I rotate that bit in the direction that it's cutting. That's what's going to happen with the chips. The down cutting is going to push those down. The up cutting is going to pull them up. We pretty much always recommend that you use an upcutting bit with origin. Almost always. A down cutting bit is going to be just a little bit harder to handle because it's going to be pushing up on the handles as you're pushing down on the router, as opposed to the up cutting bit, which as it pulls the chips up and out, actually pulls the router down firmly onto the base of your material. It just gives you a much more solid base. And as long as you're using high quality materials and a sharp router bit, you're going to get a really, really high cut quality even with the up spiral router bit, even though it has the potential to tear those upper fibers of your work. Every single time we cut on Shaper sessions, it's pretty much always with an upcutting bit, so you can go back through previous sessions and see the cut quality that we get there. Things to keep in mind there: make sure that your router bit's sharp, make sure that you're using good material. We pretty much always work with nice birch ply if we're using sheet goods. Hardwoods, piece of cake with upcutting router bits. We have two more types of edge geometry to look at. I have this straight flute router bit that I was showing you earlier. I'll bring that back on to the camera. Okay, let's look at this one. We've got our straight flute right here. This is neither up nor down cutting. This edge is literally straight up and down. So it's not really pulling the chips up. It's not really pushing the chips down. It is just cutting the chips away sideways. I like to use straight fluted router bits, maybe even a down spiral router bit when I'm doing tiny inlay work, just because removing any small amount of fuzz is greater impact to the fit of that really fine inlay work. But when I do that, usually I won't switch from an upcut to a downcut. I'll switch just from an upcut to a straight fluted router bit. It's a good balance between chip removal and edge quality. And then, last but not least, we get a lot of questions on this one on sessions. We have the compression bit. So if you look at this compression bit, it has two differently ground sections. At the bottom is an up spiral section that's only about a 1/4 inch long. And then above that is a down cutting section. Now, ideally what you get out of this is a good balance between chip removal from that small upcutting section and edge quality from that down cutting section. But these are really expensive. They are much harder to grind, as you can tell just by looking at this compared to any of these other three. They are kind of harder to use well and nail that sweet spot between the upcut and the downcut. And I don't ever use these either. We don't even sell them in the Shaper store, just because we get so little use out of them. I'm really like an upcut guy 98% of the time. Maybe a straight flute, maybe a down cutting bit when I'm doing really tiny inlay work. Looking over at my notes here because I've just got so much to cover that I needed to write it all down. So we've got the sides of the edges. Now let's talk about the ends of the router bit. We've got three different things that could be going on at the end of the router bit. We've got center cutting router bits, which are ideal for origin. We've got non-center cutting router bits, which you can use with origin, but are often not ideal. And then we've got bits with bearings on the end, which are an absolute never with origin. So let's show off those three. I'm going to start with the first, which is the center cutting router bit. Pretty much all, not 100%, but most of the bits that we sell on shapertools.com are center cutting router bits. Is this kind of in frame, Goose, down here? What do you think? Not too much. A little bit. You can kind of see it in the glint of the light. You've got these two edges that meet in the middle. That's center cutting. Now on a bigger bit here, you can really see this is a brazed carbide bit, but I've got two cutting edges on the side and this kind of cross piece here in the middle that removes material in the center. Contrast that with a non-center cutting router bit. You can see this just has bare steel in the middle. And when you plunge with this, it will not remove material from the center of the bit. You can even see where somebody tried to plunge with this and it just burned away the paint in the center of the bit. So the difficulty with using these with origin is you have to remember that you can only plunge over an area that has already been cut. Now you can cut sideways because it's got those cutting edges on the sides, but it will not remove material from the center. Now, thirdly, we've got a bearing bit. These are a never with origin. Never use a bearing bit with origin because this bearing is going to compete with origin's autocorrect function. And that's something that you can't turn off. You wouldn't even want to, even if you could. And so just never use a bearing bit with Origin, top or bottom bearing. Never with the bearing installed, at least, especially. And okay, that brings us to our first demo. I've neglected to mention this at the beginning, but because Jake's not here, we're going to get a little dangerous. And I'm going to do some don't try this at home demos today, just to keep it fun, because it's a very heavy session, a lot of information. And our first don't try this at home demo is what the heck happens if you try to plunge with a non-center cutting bit with Origin. So I'm going to show you the difference between the center cutting bit and the non-center cutting bit. This is going to be a pretty fast demo. We're going to do a couple of these fast little demos that kind of show you what can go wrong with router bits and what to do to diagnose them. Okay, so I'm going to pull this spindle out here. Let's bring over our center cutting and non-center cutting spindles here. You can see this again. Let me show this on the Origin cam just because it's a little bit closer. You can see this is non-center cutting, no cutting area in the middle. This is that center cutting bit. It does have that little crossbar right there. Let's do the fun one first. Let's do non-center cutting. This is a 3/4 inch bit. I'm going to revisit this, but the max bit diameter that you can use with Origin is 1 inch in diameter. And let's just do this super easily. Let's just create a circle that is a little bit bigger than our router bit. Let's go 0.76 inches in diameter. I'm going to place this, I think this over here a little more to the right is going to be good for the camera when it's cut. I'm going to place this right here. Cut mode. Again, we go through our settings top to bottom here. I'm going to breeze through this. I'm going to do 3/4 inch diameter. We're going to let Origin Z-touch automatically. Okay, great. I don't want to go that deep. Let's just go a 1/2 inch and see what happens. Inside cut is great. No offset is good. I'm going to turn on helix mode so it does this all automatically. And let's check our speeds. These are fine. Okay. Let's see what happens when you cut using a non-center cutting bit with Origin. Again, don't try this at home. And Goose, I think for this, you might want to stick with the front camera, or let's see what the side cam looks like. Yeah, let's do this one. Okay, awesome. All right, here we go, folks. Okay, so that wasn't working, obviously. Let's look and see what was going on here. Look at this. We've got kind of a cut around the outside where that cutting area, where those edges are. But in the middle, that's totally burned. Let's see if we can force it. I'm going to really hold down solidly here. Yeah, it's just not doing it. So this is why. Never use center cutting bits with Origin. It's not going to be dangerous. It's going to retract on you. You're just going to be like, man, what the heck? Why isn't this working? If you got this burn mark in the middle, that's because your router bit does not cut all the way to the center. It's not going to let you plunge. So let's swap now for this center cutting router bit. I've been saying lately that I want you all to try things and make mistakes at home, so I'm trying to put my money where my mouth is on this one. All right, so we've got that center cutting router bit in there. This is a little bit smaller, I think. I'm just going to guess on this one, but I think it's a 1/2 inch diameter. Doesn't matter so much for this demo. And we're going to Z-touch this automatically. Okay, lovely. We can just go back to the same circle. That cutting area is a little bit bigger. That's fine. We're going to helix this. And let's let her rip. There we go. That's a nice cut. Cool. So always use center cutting bits with origin. Rarely use non-center cutting bits. We do sell a couple of them. One of them is the dovetail bit, which you wouldn't really want to plunge with anyway. And never, ever, ever use a bearing bit. Now, let's talk a little bit more about edges, because we've got all different kinds of, we talked about upcutting, downcutting, straight flute, compression bit, but what's the difference between a finishing bit and a roughing bit? And is there something even weirder than a roughing bit? Yes, there is. Let's find out about that. So I'm going to clear out this little section over here. I'm going to keep my straight 1/4 inch router bit over just for comparison. Okay, we've got that still. And now let's look at some weirder stuff. I've got my ultimate bit kit over here. These are out of stock, but if you're lucky, we'll make more of them this year. Check this out. This is every router bit that we make currently. And I'm going to pull out, actually, let me swap out this 1/4 inch bit for the 8x35 finishing versus roughing bit. So let's talk about these two types of edges. The only difference between these two router bits is this serration that we've got going on. They're both the same shank diameter. They're both the same cutting length. They're both the same clearance length. Now, remember I mentioned that some bits have clearance beyond that cutting length. The cutting length on these is 35 millimeters. You can see there's additional clearance beyond that that's ground back so that you don't get any interference when you cut deeper than that 35 millimeters. But look at these edges compared to these edges. These are nice and smooth. These are going to give you a really smooth, let's say tenon, for example, if you're cutting tenons. Now look at the serrated edges on this roughing bit. The reason that we do this is because this allows you to remove much more material more quickly. It kind of chunks the material up and allows it to just break away faster and cleaner. The trade-off there is that you aren't going to get as smooth of a finish on the walls of your cut. So if you're doing something like clearing out a really big mortise, for example, you might want to start with the 8x35 roughing bit and then come back with the 8x35 finishing bit to just clean up those walls and make them nice and smooth. Roughing bits typically actually last a little bit longer than finishing bits also, and that's because they've got more room for things like tar and sticky wood stuff to get away. There's not so much edge for that stuff to stick to. There's more room for it to get away. And I'll show you some examples of a really gummed up bit later also. So, okay, but we're going to stick with things that cut and different types of cutting edges. We've got the straight finishing flutes. We've got the serrated roughing bit. Now, let me pull over a crazier one. This is a burr style router bit. Now, look at this when I put it on the camera here. All right, you see that? So we're talking about upcutting versus downcutting. This kind of blows that upcut versus downcut thing out of the water. It's actually ground in both directions, which makes it almost like neither an upcutting or a downcutting bit anymore. It's just got this like diamond knurled texture on it. We call this a burr bit, and these are pretty good for really stiff, brittle composites. Think like carbon fiber or fiberglass. Now, the trade-off with these bits is that they don't have a lot of flute area. Now, this flute area is the part that's been ground away in front of the edge. And the flute is where the material that you're removing goes when it's trying to get out of the cut. So because these don't have very much flute material or flute space in them, typically when they're used industrially, they're used with a really heavy like air blast to clear the dust away. When you're using them with origin, you really want to be careful just that they don't get jammed up with dust because that dust is going to prevent them from cutting. And that's going to create heat, which is the enemy of all router bits. Heat is the enemy of all router bits. So, but anyway, we've got this burr style here. And then for even more brittle materials, again, like carbon fiber, things like that, stone maybe even, check this out. This is a diamond grit abrasive router bit. So every one of these little grits, this is probably like, I don't know, 60 grit equivalent, something like that, sandpaper. Every one of these little particles is a tiny little piece of diamond. It's actually brazed to this steel shank, kind of like those carbide edges were brazed to the steel shank in the brazed carbide router bit. If you think this gets gummed up easily, this gets gummed up crazy easy. So use these, again, when you're cutting like super, super hard material, really brittle material that kind of chips away, flakes away easily. Because the diamond is even harder than the carbide is, it's like carbide is one of the hardest materials in the world. Diamond is one of the very few materials that's harder than it. But be really, really cautious with these. Like, you would never use either of these two, the burr style bit or the grit style bit, the abrasive bit with wood. You just never would, because the sawdust doesn't have anywhere to go. But if you're looking for something to route something like carbon fiber with, something that is hard enough that it's going to damage your carbide router bit, which again, very few materials are, that's when you might step up to that diamond abrasive. So, fun. Let's see. Edges have different geometries. Again, looking over at my notes here, some are sharper, some are less sharp deliberately, like thinking of sharpness as the angle of your chisel or the angle of your plane iron. Some people sharpen their chisels to 25 degrees, some people sharpen them to 30, some people put a 35-degree micro bevel on them. The trade-off there is edge durability versus outright sharpness. And this is something that's actually really important for router bits that you use with wood, because a lot of the router bits that are out there are meant to be used with metals. Metals are a lot harder than wood, and so the edge geometry that you would use for a metal is going to be deliberately actually a little blunter, not literally dull, but just a wider angle, think 35 degrees instead of 30, to give the router bit more durability in that harder material. So when we grind our router bits, I don't know the specs for every single one of them, but when we grind our router bits for Origin, especially when we're looking at these 8x35 millimeter finishing bits, like these are sharp as heck. This guy right here, these are ground to a very, very sharp angle. And so that's why I would recommend you use these with wood. These are awesome, awesome router bits. They're going to be less durable. I would not chuck these up in... they're going to be less durable with metal, is what I'm trying to say. I would not chuck these up in like a CNC mill and hog out a bunch of aluminum with them. These are very specifically designed for high material removal rate in soft materials like wood and plastics. So that's why we sell these. Can router bits be resharpened? Yes. We don't do that here at Shaper. I don't think personally that it's cost effective, but you can, if you want to, send your router bits out to be resharpened. The hard thing there is that they're going to come back with a smaller diameter. And so that's something that you're going to have to keep track of when you're entering that diameter into Origin. Now, I think I've been rambling for like quite a long time. So let's do our mid-show break. This is way more material than I expected. Let's do our mid-show break. Let's go pull that poll question up. The poll question is going to be, what router bits do you want us to add to the Shaper Tools router bit catalog? Just want to hear what you want so that we can work on that stuff. And while that's up, I'm going to go through the accessories sale one more time. Now, this accessories sale runs from... Oh, I'm going to fudge the dates if I don't look this up. This week only. Holy smokes. This week only. Save 15% on our accessories at shapertools.com. That's going to be router bits, collets, calipers. Orders over $100 have free shipping. Orders over $150 get this free router bits poster. And I'm going to pull up this photo here, Goose. So let's go ahead and switch to this. Look at this dope poster. It's huge, and it's got a lot of information on it. So you can see this from all the way across your shop. And when we go into a little bit of a troubleshooting section, we're going to focus on this so that you can see it later. We're going to zoom in on this section down here. But needless to say, this is an awesome poster, and you want it. I wish we had one hanging on the wall here, but we literally just got them in like today. So I haven't gotten around to that yet, but it's happening soon. Behind me on the next show, hopefully. So yeah, save 15% on accessories. Now's the time to do it. I think that's enough time to answer that poll question. So let's roll into our shop tour. We've got a shop tour from Neil. Reminder, if you want a cool gift from Shaper Tools, I'm not going to spill the beans on what it is, but believe me, you'll like it. It's just send us a shop tour so that we can play it on sessions. We love sharing shop tours of our community. We're looking for something that's 3 to 5 minutes long. It's going to be in landscape mode, ideally. It's going to be narrated by you, and it's just going to show off your shop. It doesn't have to be clean. It can be dirty. It can be small. It can be big, whatever. So send us your shop. And that email address is sessions@shapertools.com. So thanks, Neil, for sending in your shop tour. Let's roll it.
Hi, my name is Neil, and this is my workshop in Northwest Arkansas. Tools include a 10-inch joiner planer, a thickness sander, a router table, a Festool shop vac, a 10-inch Inca bandsaw. This is a Swiss-made tool I first purchased, I think, in about 1983. It's been a great tool for me. Lots of clamp storage, bench grinder, more clamps, a Voyager drill press with stand, corner toolbox, TV with a Mac Mini hooked up to it that I can do my design work in. Workbench is an overhead cabinet with all of my hand tools, a couple of Festool drills in there, and then a lower workbench. I built these and have really been very pleased with the combination. I think both of those are Woodsmith plans. Table saw and an outfeed table using a Festool MW1000, which has worked really well for me. Central dust collection using a Laguna dust collector. Chop saw station using a Capex, a disc sander, and a spindle sander. In the door over here, behind there, I've got a air compressor, mini split, and the floor is all epoxy. Lumber storage over here, hardwood at the top, and sheet goods down at the bottom. Other interesting tools, I do have a Joint Maker Pro that I've had for years from Bridge City Tool Works. It's a great little saw, and I'll show you some of my work inside as we go through that. Let's go inside now and take a look at what I've got inside with some projects that you might be interested in as well. Inside, I wanted to just show you some of the work that I've done. This is a dining table that's walnut on a metal welded base. This is a sideboard, also walnut with a welded metal base. These are bookcase. This is a kind of a catch-all case. Those are ash shelves on a welded black metal base. This is the kind of work that I do in my shop. All the welding I actually do at a remote farm shop that's about 3.5 hours away. All the woodworking I do here in my main shop. There's a chest of drawers that I did, also metal with the walnut. Being in Northwest Arkansas, you can find walnut very inexpensively. It's native to the area here, which makes it really attractive to do work with that. There's a couple of nightstands here also in the same design, again with walnut on the top of metal base. That's a table that I did with Mark Adams School of Woodworking. This is a chess set that I did with John Economaki, also at Mark Adams School of Woodworking, using the Joint Maker Pro and his hand planes. We've seen the luggage rack that's actually in the Shaper hub. I did that years ago, and a video is on YouTube of me designing that with the Shaper team. Shaper made nightstand. This is all Baltic birch, as well as the bed is made entirely out of Baltic birch as well. It really finished out well and was a great little project exploring what you could do with Shaper in some of the curves and such in the bed. This is a bench made from walnut and waxed paper cord that I did. And here's another table that I did. This is actually just a side table. I really like the cantilever design and have really enjoyed that as a unique kind of a piece. This is a bed that I made using plans that I found online, and a nightstand, again, similar. This is white oak on a black metal base. And then finally a stock chair. This was from the, I think I won a contest on Shaper, and they sent me the materials, and it was a fun project to build. Thanks for tuning in, and we really appreciate the Shaper efforts to teach us all about how to do more with our tools.
Awesome. Thanks so much, Neil. I got a chance to look at some of the questions while that shop tour was playing, and we got one that, I wasn't going to touch on, but let's cover it since I saw it. That is coatings. While we're talking about the bits themselves, let's go back down to the bit cam here. I hope you all are ready to jump back into this because this show's running over, and I've got a lot more to cover, so buckle up. Coatings. Okay, shapertools.com. We pretty much only sell router bits that are uncoated. You will see out there some with the Spectra coating or this yellow, I think this is, well, I don't even know what it is, but this yellow coating. These are coatings. These coatings will purport to give you a longer router bit life. The way that they do that is by lowering the friction, typically, on the surface of the router bit so that they clear chips better. The trade-off with coatings is that A, they're another process in making the router bit. B, they are expensive. Well, A leads to B. And then also that they do actually have a thickness. And we talked about the thinness or the angle of that edge leading to the cut quality of the bit pretty directly. The thinner the edge, the better that bit is going to be cut at shearing the wood fibers and cutting those. And so actually uncoated router bits typically are going to be the absolute sharpest. And that's just what we sell. They're a little more economic. And they work awesome for me. I've never really felt the need to buy a coated bit. One man's opinion. Okay, we got that. Now, I think that's everything about the literal bits themselves. I know that was a lot. Let's talk about how the bits attach to Origin, the router, via the collet and the spindle. And then we will talk about cutting with bits, what to do, what not to do, some troubleshooting opportunities, and we're going to try to make some more bad cuts. So here we go. Let's talk about collets very briefly. This is a collet. Let's show this off on the bench cam here. This is the collet you know and love. Origin comes with a 1/4 inch collet for 1/4 inch shank cutters. This is the 8mm collet that I'm going to be using just to chuck up the 16mm router bit that I have. The most important thing with these is that you only use the exact size shank that is printed on the collet. So this is an 8mm collet. Only an 8mm shank ever goes in here. For a 1/4 inch collet, same. Only ever a 1/4 inch. So we're going to drop this in to Origin kind of loosely. Don't over tighten these because that can damage the collet without a router bit in there. And let's talk about this bit. Now I'm going to clear out the bit cam here again and pull up that K mark one more time so that you can see that. See that K mark right there on the bit? That is our minimum insertion length. Okay, remember that. So we're going to come over here and drop this router bit into the collet. Now, I think the best place to do this is on the Origin cam. See that K mark? That is your minimum insertion length right there. Now, there are a lot of times where you might want to bring that in even farther. The reason for that is because of rigidity. Not going to bore you with the equation, but it's a cubic function. So every time you double the length that a router bit sticks out of the collet, you cut the rigidity of your entire setup by a factor of 8. So 8x. 2 cubed equals 8. If you stick out the router bit 1.5 times instead of 2x, it's going to be 1.5 cubed. So the gist of that is that you want that router bit to be seated as far in to the collet as you practically can for any given cut. The flip side of that is that you don't want to seat the router bit too far Now let me pull that 8x35 bit back out and show you something that could happen there. So on this 8x35 bit, let's look at this here. You've got this clamping area here, and you can see this step down. Now, you only ever want, again, to clamp on exactly the right diameter that the collet is. So you might think, hey, I want to choke up on that all the way. But going past that shoulder, that's very bad. You don't want to do that because you're actually losing clamping area on this router bit. You also don't ever want to clamp above the cutaway flute area on your router bit. So with this bit, I would say keep an eye on that shoulder. Now, okay, going back to how far in can you go? The other thing with this bit, because it's so long, you can, in theory, bottom out this router bit. Do not bottom out your router bits on the back of the spindle because that could theoretically prevent the collet from clamping down all the way as you tighten it, because as you screw it in, trying to pull the router bit in. And so if you're back against that hard stop, that is not good or not ideal at minimum. So that's most of what you need to know about the collets. One last thing that you should know about the collets is that when you get to the smaller sizes, looking at how far you need to clamp things in them, might be a little difficult to see, but if you look at the back of the collet, you can see that it's actually a larger diameter in the back here, and it's necked down to that 1/8 inch diameter at the front here. So what needs to be in contact with the collet at minimum, if there's no K-mark, it needs to contact the entire clamping face of the collet. And for the small collet, that goes about halfway. For the 8mm collet, it's a little longer. It's pretty much all the way to the back. But you want to make sure that that router bit is engaged with the clamping length of the collet itself. Okay. Again, maximum router bit diameter for origin is 1 inch. Minimum, as small as you want to go. I've used a 1mm router bit with origin. That's 0.04 inches for milling brass, tight details on brass, and that's worked great. You're going to want to make sure you turn down your auto speed a lot and make sure you use manual touch off instead of automatic touch off when you're doing your Z touch with origin. I've used even as small as 1/64th, which is 0.016 inches for doing fine details on inlay work with wood, and it's worked just fine with those soft materials. So keep that in mind. Now the last demo that I wanted to do is to try to make some bad cuts and troubleshoot speed settings, both auto speed and spindle speed for origin. Before we do that, let's pull up this detail photo that I've got from that router bit poster so that you can see like some of the awesome information that's going on in here. So let's go ahead and pull the computer up, Goose. Here we go. Feed rate versus spindle speed. This is directly to do with router bits and how to get the most out of them. Feed rate, this is AKA your auto speed, slow to fast. Spindle speed, this is that dial on the spindle, 1 to 5, slow to fast. Now, if both are slow, that's going to give you a bad material removal rate and a long finishing time. It's not going to harm the router bit necessarily. It's just going to be slow. Everything's going to be slow. When you're milling or routing with especially CNC tools, you want to maximize your material removal rate. That is the literal volume, cubic inches or cubic centimeters of material that you're removing for the amount of time that you spend in the machine. So if you're going too slow on both counts, not going to hurt too much, but it's going to be slow. If you keep your auto speed slow but move up your spindle speed, the tool will rub rather than cut. And that rubbing creates friction, which is going to lead to burning. Burning is like the #1, and heat, like I mentioned, is the #1 cause of death of router bits. So the last router bit I have to show on the bit cam here is one toasted 1/4 inch router bit. Look at this. This got too hot. Carbide can tolerate quite a lot of heat, but what happens when bits get too hot is they burn the wood around them. The organic materials from the wood attach to the bit, or plastics melt and attach to the bit, metals weld to the bit. And these materials attaching to the bit are going to increase the friction, which is going to, it's a vicious cycle. It's just going to make even more heat. and it's going to be even worse for the bit. And those heat cycles are what degrade carbide. It'll stay sharp for a long time, even with this nasty stuff on it. But the nasty stuff is going to keep increasing the friction. It's going to keep increasing the heat. And over time, that will degrade the bit and it'll start to chip away. So keep your bits clean. We're going to do a whole different show on keeping your bits clean later. But the takeaway here is to keep your bits clean. Back to the screen. In the middle here, you've got kind of a moderate feed rate for your material, spindle speed. The higher you go, you might get a little bit better of a surface finish. The slower you go, you might get a little bit better of tool life, but kind of in a moderate feed rate and a moderate spindle speed for the right material, you're going to be pretty happy. Now, fast feed rate and slow spindle speed, this is another bad thing. Chip load too high. Bad surface finish because you're taking big, chunky cuts out with every time that router bit comes around. And poor accuracy also because you're going to be fighting Origin a lot, especially because it's a hand tool also. It's a CNC machine, but it's also a hand tool. Best of both worlds is the maximum feed rate and maximum spindle speed that you can keep up with. That's going to give you the best possible material removal rate and the shortest machining time. But it might take you a little bit of experimentation to get there. You can always play it safe by slowing things down just a little bit. And with some practice, you can speed it up and find that perfect Goldilocks spindle speed and feed rate. We've got even more troubleshooting info on this poster. Again, that's included with accessory sales or any purchase on shapertools.com over $150 this week. And that accessory sale is 15% off. Now, I think the last thing that I want to do is just try to make some bad cuts on purpose and show you what it looks like when your spindle speed is too high and your feed rate's too slow. What it looks like when your feed rate's too high and your spindle speed's too slow. That's the inverse problem. And try to find that Goldilocks right in the middle. So we're going to leave this 1/2-inch diameter center cutting brazed carbide straight flute router bit in here, because I'm pretty sure I can make this burn. I don't think I can make a fresh 1/4-inch upcut router bit burn even if I tried. It would take a little while. And we're just going to design some straight line cuts with Origin. So we're going to go in here. I don't even really need to grid this just to make some lines to cut. I'm going to go into pen mode. I'm going to click and drag that across. Double click to finish. Let's make a couple more. We're going to try to do one too slow, one too fast, and one just right. We're going to create another line. Click, drag, double click. And this would be a good opportunity to prepare your questions because we're about to roll into that Q&A section. If you haven't sent in a question, make sure you go ahead and ask that. And Ted will send that to me to answer shortly. Okay, so we've got 3 online cuts. These are just going to be straight across, safety glasses on. And the first one that I'm going to do, I'm going to try to do it too slow so that it burns. And what that means, again, is spindle speed too high and auto speed too slow. So let's go into cut mode here. I'm going to keep these settings. I'm going to keep a 1/2-inch online, no offset with online cuts, 1/2-inch router bit. We already Z-touched. Let's do it again just for good measure. Okay, and okay. Well, let's roll with it. I Z-touched it before. And let's do auto speed. We're trying to burn. So high spindle speed, low auto speed for this one. Let's go with 2. And we're gonna crank that spindle. Let's set this at 5 out of 6. Even that's gonna be too fast. We're not even gonna go all the way to 6. Let's see what's gonna happen here. I'm gonna double click to start and go into auto lock mode, which is where Origin's gonna set the pace and I just keep up with it. And we're gonna see how long it takes before I smell burning. Here we go. I didn't do this before the show. We're just gonna see how it goes. Oh yeah, that's toasty. I don't know if you can see that. Can you see that on the overhead cam maybe? It's like even warm to the touch around this. Not super well. Let me pull out this bit. So, okay, so what happens here? You can smell burning when you're cutting. You see a little bit of char on your project. You think, okay, I should slow down my spindle speed or turn up my feed rate. Oh boy, look at that. That's something. Here, let's show that on the origin cam. Carbide's very durable, frankly, so like we might be able to just kind of blast through this and clean this up by giving it a nice heavy cut. So the next thing that we're going to try, we're going to overcorrect here. We're going to go low spindle speed. I'm going to turn it all the way down. Oh my goodness, this is kind of nerve-wracking. And I'm going to turn my auto speed up. Let's set this at, what do you think I can keep up with, Goose? 20? Let's do 20. 20 feels fast. That's twice the default. Let's see what happens. Oh, that just took off on me. And it retracted because we basically overloaded, like we overloaded the tool. That was heavy. Let me turn this down to 15 and see if I can keep up with it. Okay. Oh. Auto lock. Auto lock. Yeah. I'm losing it. But you can see, though, that this is, you probably can't see on the overhead cam. Maybe you can see the contrast between the two of these. This is already so much lighter. I'm having the inverse problem. This is literally the problem. You're like overloading everything. And I can't keep my hands on the tool. It's just retracting because it's like it's jumping out of my hands. But you can see also, though, it's not awesome. Yeah, I'm going to put it on the origin cam here. It's not awesome, but you can see even just taking that heavier cut kind of cleaned this bit up. This is not the right way to clean a bit, but you could tell that it's healthier for the bit. It's just not a cut that I can wrap my hands around. So, I think I've got an idea of the Goldilocks here. I think I'm going to set my spindle at like 2.5 or so, because this is a pretty big bit, 1/2 inch diameter. I am going to turn that auto speed down a little bit more. I'm going to set this at 8. Let's do 1/2. Yeah, nice. Okay, here we go. And I forgot auto lock last time, so I'm going to make sure to do that the first time here. Double click the green button. Let's go to the overhead cam. I didn't need to go all the way across that, but you can see that. That's awesome. I probably could have turned the spindle speed up just a little bit. Maybe it's just starting to turn a little bit of a darker shade in there. Probably wouldn't push it. Really should be taking a lighter cut on this. This is a 1/2 inch diameter bit that is plunged literally a 1/2 inch straight down in the material, because I really wanted to push it so that I could show you guys what the extremes look like. But this is like a perfectly straight line. It's really good cut quality. I do need to clean the top up just a little bit because that bit got kind of charred, and so it's not super, super sharp. But it's a straight cut. I was able to keep my hands on the tool. Super high material removal rate there. That's like a huge cut for one pass, 1/2 by 1/2. And that's awesome. I'm really happy with that. That's the Goldilocks moment right there. And we will see you in 2 weeks. Thanks.